Hi, so this video is on simplifying square roots. So let's first talk about a square root that is a perfect square. So for example, if I have the square root of 25, most of us know that the square root of 25 equals 5. And that is because 5 times 5 equals 25, and the square root is asking us what number, when I multiply it by itself, gives me this number underneath the square root, right? So because 25 is equal to 5 times 5, and there's two 5s underneath, that means it's equal to 5, okay? Now, 192, that is not a perfect square. And what I mean by a perfect square is when I multiply a number by itself, it gives me a perfect square. So, like 1 times 1 equals 1, so 1 is a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square, and so forth. So like the number 5 is not a perfect square because there are no two whole numbers that I can multiply together that are the same to get 5, right? So 25 is a perfect square because that's 5 times 5. So that's what a perfect square is, but 192 is not. There's no whole number that when I multiply it by itself, it gives me 192. So when we're asked to simplify a square root, if it's a perfect square, okay, well that's just the number that multiplies to get this number, right? If it's not a perfect square, we have to find the parts that are and take those out front. And anything that's not a perfect square has to stay inside of the radical, okay? So what we're going to do here is we're going to break down 192 to its prime factors. So what is a prime number, okay? A prime number is a number that only multiplies by, or the only two numbers that go evenly into it are itself and 1. So, for example, 5 is a prime number because there are no two numbers that multiply to 5. 4 is not a prime number because I can do 2 times 2 or 4 times 1. But see, 5 I can only do 5 times 1, and that's why 5 is prime. So 6 is not prime because I could do 2 times 3 or 1 times 6. So 6 is not prime. But 7 is, because the only two numbers that multiply to 7 are 1 times 7, okay? So we want to break this down, and we don't want to stop until we hit prime numbers. Now, when I get a prime number, I'm going to circle the prime number, okay? So 192, I can see it's an even number, so I know 2 must go into it. I can take any two numbers that multiply to 192 and start there. So it doesn't have to be any specific order. Just make sure that this number actually does go into 192. So 2 goes into 192. 2 times 96 is equal to 192. So 2 I'll circle because it's prime, but 96 I can break that one down further. Again, any two numbers that multiply to 96 will work here. I'm going to put 3 into 96, so that will give me 32. 32 is 2 times 16 or 4 times 8. Either one will work. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. Okay? So I've circled all the primes. Now if I were to multiply all of these prime numbers back together, I would get 192, right? So I'm only looking at the prime numbers here. I'm not going to look at 96, 32, 16, 8, or 4. Okay? I'm only looking at the primes. And what I'm doing is I'm looking for pairs because I know that any two numbers inside of a radical or a square root is equal to one of them on the outside, right? So what I'm going to do is look for pairs, and anytime I find a pair, I am going to cross them out and bring a 2 in front of the radical, okay? Or whatever the number is. It doesn't have to be a 2. Then I'm going to find that there's 2 more here, so another 2. Now anything that comes out is going to get multiplied together with anything else that came out. There's a 2 here and here, so that's a pair. So I can bring one more 2 out. This 3 is alone, right? It's not a perfect square because there's only one of them. So it has to stay underneath. So now I would just finish this off by multiplying back together 2 times 2 times 2, which is 8. And that 3 would stay under the radical. This is the simplified form of the square root of 192. So we want to keep it in exact form, meaning we don't want to change it to a decimal approximation of what it equals. We want to keep it exact. But we want to simplify what's in the square root as much as possible. So the square root of 192 and 8 times the square root of 3 are equal but this one is more simplified. So that's our goal. Okay, so let's try a couple more examples. All right, so we have the square root of 48. So again, first step, we're going to break this down, and we're trying to find any two numbers that repeat inside here. I can see that 4 goes into 48 12 times. 4 breaks down to 2 times 2. 12 breaks down to 4 times 3. And 4 is 2 times 2. So now I'm looking for pairs. So if I have two 2's inside, that means I can bring one of them out. Same thing here. But that 3's alone, it's left inside. So this would equal 4 times the square root of 3. That would be our simplified form. Okay. On the next one, I would like you to try it on your own. Pause the video, try it on your own first, and then once you have it, come back and compare the answer here. Okay. So square root of 45. If I break this down, I know that 5 times 9 equals 45, and 3 times 3 is 9. So now I see that there are 2 3's underneath, so I can bring a 3 outside, but this 5 will have to stay inside because there's just one of them. So 3 square roots of 5. So let's just do like one more like this. And again, it might be a good idea to pause it and try it out and then come back and see how you did. Let's see, 384 is even, so I know I can put a 2 in there. Alright, so 384 divided by 2 is 192. 192 is also even, so I could divide it by 2 again. 2 goes into 19, that'd be 81 times. No, that's not right. 96 times. 96 is 3 times 20, 32. And then 32 is equal to 8 times 4. 8 is 2 and 4. 4 is 2 times 2. And then we have 2 more 2's. So we've got a lot of numbers here. Now we're looking for pairs. So anything that happens twice, I'm going to cross it out and bring just one out front, because 2 underneath the square root means 1 outside. So another one there. Another pair here. And this 3 and this 2, they both are loners. They don't have a pair. So they are going to stay inside. I will multiply them back together on the inside. So 2 times 2 is 4, and 4 times 2 is 8. And then 2 times 3 is 6. So 8 on the outside and 6 on the inside of the radical. Okay, let's go ahead and try something just slightly different. So I'm going to skip ahead a little bit here just to get one that looks a little different. Okay, here we go. So we've got negative 6 times the square root of 128. So we're going to go through the same process here. We're still simplifying what's under the radical. The negative 6 out front will just get multiplied by anything that comes out of the radical. So 128, let's see, I could do 4 times 32. 32 would be 16 times 2 is one way anyway. Oh, whoops, I circled a 4. Shouldn't have done that, right? 4 is not a prime number. So let's try that again. 4 is 2 times 2. 16 is 4 times 4, and then each of those give us 2 2's. Alright, so now I'm looking for pairs. So if there is a pair of 2's underneath, I can bring one out. Now there's already a negative 6 out here. That negative 6 is going to get multiplied by anything that comes out. So 2 2's here. And 2 there means I can bring out 3 2's. That 2 has to stay underneath the radical. Negative 6 times 8, right? 2 times 2 times 2 is 8. Would be negative 48 times the square root of 2. And there's our answer. Okay? So if you see a number in front, that number just gets multiplied by anything that comes out of the square root. Okay? I guess let's do one more of these. And again, I recommend you pause the video and try it on your own and then check your answer. So 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So we've got a bunch of 2's in here. We're going to look for pairs of them. So every time I have 2 inside, it means I can bring 1 outside to multiply by -7. So I can bring out 2. That one is alone, so it has to stay underneath. So -14 times 2 is -28 roots of 2. All right, so there's just one more type of example that I want to look at here, and that is just when we involve variables. So let's actually, let's do this one. So I want to kind of ignore the variables at first. I'm first just going to look at 12, and I'm going to break it down the way we have been. So 12 is 3 times 4, and 4 is 2 times 2, so I'm circling the primes. So I have 2 2's underneath here, which means I can bring out 1 2, but the 3 is going to have to stay underneath the radical because it's all alone. That's a radical, by the way. The square root symbol is called a radical. Okay, b to the 4th power, that means b multiplied by itself 4 times, right? So just as I did with the numbers, if I have any numbers that repeated twice, I can bring 1 outside. Same thing with the variable, because b times b, that's the same number being multiplied. So I can bring out a b for those 2, and I can bring out a b for these 2. b times b is b squared, so this would be 2b squared square roots of 3. Okay. So let's just do one more like this. Again, I recommend that you try it on your own and then come back and watch the answer and see how you did. 27 is 3 times 9, and 9 is 3 times 3. So I'm looking for pairs. So I find a pair of 3's here. It will come out. That one's alone, so it has to stay inside. I have x to the 3rd power, which means x multiplied by itself 3 times, but I can only take 1 out when I have 2 the same, so that one's alone and has to stay inside. So 3x on the outside and 3x on the inside. Okay. So go ahead and give these a try. If you have any questions, you can email me, and we'll see you next time.